Today's lesson is 12.5 independent and dependent events. This is for pre-algebra people. The key concepts are probability of independent events. That's the first concept we're going to deal with. And say I have a probability of A, then a probability of B. You would just multiply them together and you would find your answer. So, you roll a number cube. So immediately I know a number cube has 6 numbers on a number cube. So 6 will always be at the bottom. And you're going to roll it twice. So I'm going to have 2 fractions that have 6. And first of all, you have the probability that you get a 2 on the first roll. Well, there's only one 2, so here's the probability of a 2. You have only one 2 on a number cube, so it's going to be 1 6. And the probability of getting a number greater than 4 would be the numbers greater than 4 are 5 and 6, so you have 2 possibilities on that one. So you're going to multiply 1 6 times 2 6. 1 6 times 2 6 equals 236. And then you could reduce it, which is 1/18. So there's your answer. Alright, then I'm going to go down to this one that's next to 1/18 that says 6, then a number greater than 4. This is kind of how your homework looks tonight. So what is the probability of getting a 6 on the first number roll? That would be 1 6. Again, you only have one possibility on a number cube. If you forgot what a number cube has on it, it's 1, 2, 3, 4, 5, and 6. And then this time they want you to find all the numbers less than 4. Well, the numbers less than 4 are 3, 2, and 1, so there are 3 out of 6 to get. Now, I'm going to show you a different way to do it. You can reduce ahead of time. I can reduce 1 and 2, and then multiply it. 1 times 1 is 1, and 6 times 2 is 12. But if you want to do it afterwards, you can. It doesn't bother me. Okay, what is the probability of getting a heads, then a head? I did H and H. Tossing a coin twice. So, again, there's only a head and a tails on a coin. So, it's 1 out of 2 chance of getting heads, and then tossing it again and getting 1 out of 2. And then you can't reduce anything, so it's 1/4. So there's your answer for the third problem on example 1. We'll go to example 2 next. Alright, example 2 is a word problem. And notice it's in percentages, so pay attention to how I do percentages. Under the best conditions, a wild bluebonnet seed has a 20% probability of growing. If you select 2 seeds at random, what is the probability that will grow? That they will grow under the best conditions? Okay, so first of all, the probability of the first one growing is 20%, and the probability of the second one is 20%. Now, you can't multiply with percentages. You have to turn them into decimals. So you have to remember you have to move it over twice. So it's 0.2 equals 0.2. So, again, probability. The probability of independent events formula is 0.2 times 0.2. If I do it, I'm going to put it underneath each other. So 4, but there are 2, so I need to move it over 1, so it's 0.4. And then you're going to turn it back into a percentage. So again, percentages, you move it twice to the right. So it's 4% chance that they'll both grow. So that's how you're going to do your homework for round 2, the nearest whole number on 7, though, on your homework. All right. Whole percentage, sorry, a whole percentage. All right, next problem. Okay, so now we have another key concept we have to talk about. That's the probability of dependent events. Now, the first event is always independent, but the second event always is dependent. So if I look at it, you're also multiplying them, but the probability of an A will be just fine, but with probability of B after A means I took something out of the situation and you have a new amount of numbers. So if I look at it, I have example 3. I have 3 girls and 2 boys at an assembly. What is the probability of picking a girl then a girl? Okay, so first of all, how many kids do I have altogether? So if I look, I have 3 plus 2, which is 5. I have 5 kids altogether. Now, what's the probability of me picking a girl at first? I have 3 girls, so that's the first probability. Now, I took out 1 girl. So now I have 2 girls left and 2 boys left. So I have 4 kids to choose from this time. And what's the probability of me picking a girl again? So if looking at that one, I have 2 girls now to choose from. So again, you can reduce ahead of time. So I'm going to reduce 2 and 4. So 1 and 2. Can't reduce 3 and 5, or 3 can't go into 2 and 1 can't, well, 1 can go into 5, but who cares? So then you multiply 3 times 1 is 3, and 5 times 2 is 10. So you have a 3/10 chance of me picking a girl than a girl. Okay, you also have what we have at the bottom here. I did something that says without replacing. And I made some boxes that have the letters Miss Carson on it. So I'm picking, it says, what's the probability of me picking an S? Well, I pick an S. 1, 2, 3. I have 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. Okay, now I took out just one S. Just one S. How many letters do I have left now? I have 9 letters left in my little bag. And what's the probability of me of picking an I? A vowel. So 1, 2, 3. I have 3 vowels. For you who forgot, A, E, I, O, and U. And sometimes Y is considered a vowel. Consonant is all the other letters. So now I can reduce. I have 3 and 9 could be 1/3. And I could reduce the 3 over here and the 3 over here, which is 1 and 1. But if you don't want to reduce until the end, that's fine too. So it's be 1 times 1 is 1, and 10 times 1 is 10. So there's a 1/10 chance of me picking an S than a vowel. And that's how you would do your lesson. Goodbye.